you want to find the videos, you just have to go to the school website and then just click on the little link. It'll take you to the YouTube.
What's the YouTube video? What's your channel called?
I don't have a name for my channel yet. I just figured it out this morning. It's very interesting. Because I don't know how to use YouTube, so I'm learning.
What's the video called?
Look it up on YouTube.
I was gonna YouTube it, but
Yeah, exactly.
how to make YouTube channel? Okay.
Well, how is it on YouTube?
Just click the little link on the thing. Then you can tell me the name of the channel, because I don't know. It didn't say like enter channel's name or anything.
It should have.
I know.
It's whatever you're using.
Okay. Doesn't really matter, kind of irrelevant. So we're going to solve this equation, and the only thing that you'll notice that is different about it is that there's a radical in there. Whenever you're working with radicals, I'll tell you this 3 or 4 times, you always have to check your answer because you get these like extra answers that don't make sense. So we'll talk about that in a minute when we define it officially. But it should be a yellow flag to you that when you see a radical in an equation, you're going to have to check your answer. So when you produce your answer, make sure you go back, check it, plug it in, make sure it works. So, how am I going to get rid of the square root? Square it. So, is it wise for me at this point in time, right at the beginning, to square both sides?
No.
Why is that unwise? Raise your hand. Hunter. And what will that do? It will make it look funny. What will it force me into? The distributive property, right? I want to try to avoid that. I mean, it's fun, but not that fun. So what is your proposal then? What should we do instead? Subtract 2. So this will be radical x plus 1 equals positive 2. Now is it wise for you to square both sides? Yes. Remember, we can do anything that we want to one side of the equation as long as we do it to the other side as well. That's why we say square both sides. That's what we're going to do.
Because the next one's going to be harder.
Okay, now, what do I need to do with my answer? I need to plug it in and check it. So, 3 plus 1, 4. What's the square or radical 4? 2. Does 2 plus 2 make 4? Yes, so I checked it. It works. I didn't get extra answers that didn't work this time. I'll let you know about a few hints to look for as to that happening in a minute. But first, you get to try one on your own. What is difficult about this one?
4.
What? What?
How long do you need? 1 minute?
What?
Make sure you check it too. Done? Oh.
Give them a harder one.
Once you get your answer, check your answer with the person to your left or right. That way, at least if you're wrong, you're wrong.
We got one of those big things from Costco. It's so bad. It looks like tape.
Square.
of the comments that kind of came out from this was, well, can I subtract the 1 first? And I cannot do that because remember that when you take radical 4x plus 1, it's the same as 4x plus 1 all raised to the 1/2. In order to get into the argument, you first need to get rid of the radical. In other words, how do you get rid of the exponent of 1/2? You do what to both sides? Square both sides. So we're basically just saying this and say, hey, square everything. Kind of looks awkward, but that's what it means. So this is 4x plus 1, and then 3 squared makes 9. See how the 1/2 exponent multiplied by the 2 exponent, 1/2 times 2 makes 1. So that's how I get 4x plus 1. Subtract the 1, divide by 4. Did you check it? Okay. Okay, good. So when you solve, I told you this already, but I'm going to tell you again. When you solve a radical equation, it's very important that you check your solution. Sometimes you'll obtain a number that does not satisfy the original equation. These numbers are called extraneous. Extraneous solutions are solutions that appear to work until you check them and you realize they don't. You can use a graphing calculator to predict the number of solutions to determine whether or not your solution is reasonable. So, if you don't know how to do that, I'll show you sometime after school if you want. Okay, example 2, let's work through this one. Similar to example 1, but what's different about this? Radicals on both sides. You knew the plot would thicken. Okay, so is it wise, is it prudent for me to go ahead and square everything at this point?
Yeah. Why not?
This juncture. So I see some of you say no, some people say yes. So Waverly, what would you do differently before you square both? So like add radical x to both sides and then combine it all under one radical? No, you can't. Because remember, these are apples. The radical x minus 15. That's an orange, radical x. I can't put them together. I can't rewrite them so they're both apples either. I could. I don't think it would necessarily help because you're still going to have to use the distributive property. And it might be easier to use the distributive property with 3 minus radical x than it would be with radical x minus 15 and plus radical x. So I think it is wise at this point to just go ahead and square both sides. So this will give me x minus 15 on the left side. And now on the right side, I have 3 minus radical x, and that whole thing is being squared. So don't forget here to distribute, because you're going to have to worry about the middle terms. You should get 3 terms in your answer here on the right side. Because this is 3 minus radical x times 3 minus radical x. See how you have to distribute? So what does 3 times 3 give you? 9. So we're going to do 3 times 3. That's that. No, I'm not. It doesn't even look funny. It's
exactly what it looks like.
I don't.
It's supposed
Where?
to look really orange.
Okay. I think it's not a face. So 9. And then minus 3 radical x. Minus 3 radical x. What does negative radical x times negative radical x give me? Well, negative times a negative makes it positive, and radical x times radical x is radical x squared, or x. Okay, any apples, anything to combine together? I can. So this is now x minus 15. And then I have 9 minus 6 radical x plus x. Okay, remember from algebra 1 when you have x's on both sides, what do? Try to get all the x's to one side. So subtract x from both sides. and subtract the 9. Can I do all that at once? Okay. As long as you're okay with it, I'm okay with it. Divide by -6. So what is 24 divided by -6? So now 4 equals radical x. What do I need to do both sides? Get rid of the radical, you need to square both sides. What do I get? $16? I'm not taking the square root of it, I'm just squaring both sides, so 4 squared is positive 16, right? Okay, now what do I need to do? Am I done?
Check
No, gotta check it. So, what is the square root of 16? 4, what's 3 minus 4? -1 on the right side. 16 minus 15, 1, what's the square root of 1? 1. Does 1 equal -1?
No.
No. So now what?
I don't know. That's not possible.
So the only solution that we produced was an extraneous solution. So are there any real solutions? No. So don't feel like it's pointless that you did a whole bunch of work and you got no solution. No solution is still a solution. You just realize that the solution is no solution. So in other words, the set of answers, here's the set, here are all the answers. What's in there? Nothing. So you discovered that. That's an accomplishment. So don't feel like you wasted your time. It's not a waste. Okay, can we go on? Okay, this one's yours to try. You don't know that. You prove it. Where'd it go? Where did you go, recorder? Where are you? So what? How about example 3?
Let's do it. We can do it on our own.
So,
Casey, let's not do that.
what should you do, Gus? Divide by 3 because of the 3 in the front. But then you're still going to have to deal with this -2, right? So let's add 2, and then let's do the dividing by 3. Because we're going to try to get this radical alone, the 1/3 part. So to do that, I'll add the 2 first. And now I'll divide by the 3. Now, how am I going to get rid of something that is being raised to a 1/3 power? I would cube it. Yep. If I take the whole thing, both sides of the equation, and I cube everything, remember when I have a power that's raised to a power, what do I do with the exponents? Multiply, and 3 times a third makes 1. So that's why I'm cubing it. Also remember that when you raise it to the 1/3 power, like x to the 1/3 means cube root of x. And how you would get rid of that is by cubing both sides. Okay, so we're going to go ahead and cube both sides. That leaves us with 5n minus 1. And on the right side, what is 2/3 all cubed? Remember, 2/3 cubed means 2/3 times 2/3 times 2/3. 8/9. And that's 5n minus 1. 9. 3, 9, 27. That's the last time I listened to Hunter. So what are we going to do to both sides? Add 1. Okay, so when I add 1, how many 27ths am I adding? 27. So the 27 sevenths plus 8 sevenths, 35 sevenths, 27ths. And how do I get the n alone now? Divide by 5 or multiply by
Reciprocal.
1/5. And can I pre-reduce on the right? This 35 makes, and the 5 makes 1. So I have 7. 27ths. And what will I do with my answer? I will check it. Are we making mistakes? Okay. So 7/27 gets plugged in, and then I'll make sure it works. So what is 5 times 7/27? 35 27ths. So subtract 1. 35 27ths minus 27 27ths is 8 27ths. And what is the cube root of 8 27ths?
2/3.
Hey, it's 2/3. So now I have 3 times 2/3. What does 3 times 2/3 make? 2, right? 3 over 1 times 2 over 3. 3 is pre-reduced. So 2 minus 2, does 2 minus 2 make 0? Hey! It checks. Now, you could check your answer using a calculator, right? If you enter this into the y equals, and then you enter the x value of 7/27 into your table, you should get an output, a y value of 0. If you do, that means you've just checked it. So should you wish to use a graphing calculator or a graphing calculator app, you could do so to check your answers, if you don't want to do all of the arithmetic. Any questions on example 3? Oh man, we're doing great on time. Here's one for you to try then. Which one? Okay, so there are two things that are going on in this inequality. First thing you're going to do is just solve it like you normally would. So let's start with that. Should I square both sides right now? No. Subtract the 2 first.
Wait, is that 2 plus?
Yes, it is. Okay, so now we're going to square both sides. So I have 4x minus 4 is less than or equal to 16. Add the 4 and divide by 4. Okay, now this is not your solution necessarily. Sometimes it is, sometimes it isn't. Can anybody determine or tell me why? What else? There's another thing I have to consider in this problem. You can think about it. There's some other constraint, something else that prohibits me from saying x is just less than or equal to 5 always. Hi. What needs to be greater than 0? This x here needs to be greater than 0? You're on the right track. Something needs to be greater than or equal to 0. What does? 5 is definitely greater than or equal to 0 at all times. But what else? Remember, when we get answers, what are we supposed to do when it's an equation? You plug it in and check it. And where does it usually not work if there's a problem? With the radical. So we're going to have to take what's in the radical, this 4x minus 4, and make sure that it stays what? Positive. So the other thing I'm going to consider here is the argument. Remember, that's the thing under the radical. And that argument needs to be greater than or equal to 0. So I'm going to solve that inequality as well. So when it's at radical inequality, you need to solve it like you would an equation, but then also consider the fact that the radical can't be negative. So I'm going to solve for that. Add 4, divide by 4. X is greater than or equal to 1. Now, this splits my coordinate plane into 3 parts. So if I consider the number line, I have really 3 regions. There's 1, there's 5, and 3 regions. 1, 2, 3. 1 less than or equal to 1, 1 between 1 and 5, and 1 greater than or equal to 5. You need to substitute some values in and check one value from each region to determine where your answers really lie. Okay. So how do you do that? Well, what's a number less than or equal to 1 that's easy to plug in? 0. So let's do that. 4 times 0, 0. 0 minus 4, can I take the square root of negative 4? No. So 0 doesn't work, which means all of the numbers to the left of 1 don't work, so they don't work. How about any number between 1 and 5? 3. So I have 4 times 3, 12. 12 minus 4, 8. Can I take the square root of 8? What will the square root of 8 be about? 2 something, right? Not quite 3, because the square root of 9 makes 3. So will 2 plus 2 something be less than or equal to 6? Yeah, hey. That's good. And Star Wars theme coming in. So, greater than 5? 10. You would pick 10. 4 times 10, 40. Minus 4, 36. What's the square root of 36? What's 2 plus 6? Is 8 less than or equal to 6? So this helps to determine where my solutions lie. Between 1 and 5. Now, are 1 and 5 themselves included in my answer?
Yes.
How do I know? Because there's a bar under the thingamabob. Right there. Couldn't be clearer. There's clearly a bar under the thingamabob. Because it's less than or equal to, yes, I'm going to include 1 and 5 in my solutions. Ian. So what if you plug in 5? 5 times 4 is 20, minus 4 is 16. The square root of 16 is 4. And 2 plus 4 is 6. Is 6 less than or equal to 6? Yes. So that would be my solution set. And if you remembered from chapter 2, clearly I remember, you have to write that in set builder notation, right? So, minor detail, but keep it in mind. Okay, ready to try one?
Yeah.
This worked out perfectly.
Why is this so